Okay, good morning students. In the previous class we had the discussion about tropic levels, tropic structure, then we had the discussion about the food chain, then types of food chains, how the food chains present in the ecosystems are going to construct the food web, and how the food web is going to be formed. We are discussed about these things, and probably I hope that you followed what I delivered in the previous class. And today let me consider the next aspect in the ecosystem. That is energy flow in ecosystem. Energy flow in ecosystems. You all know that what does it exactly mean by energy? Energy is supposed to be capacity to do work. Like that we define energy in physics. All living things needs energy. Without energy, living things can't survive. The reason is energy is very important for the metabolic activities. Suppose if the organisms want to survive, in the body of organisms, many metabolic processes or activities should take place. For example, you consider the process like growth. Even you also consider certain processes like synthesis of carbohydrates, synthesis of proteins, synthesis of lipids. They are all going to occur at the cost of energy. Even energy is also must for the fundamental activities of the organisms, such as the reproduction. Even it is also very much necessary for the processes like excretion. Even the process like cell division, it also occurs in the presence of energy. Without the energy, cells of the organisms can't survive. If at all cell want to survive, definitely these fundamental activities must go on. And all these activities which are supposed to be taking place at the cost of energy. If energy is not given to the organisms or cells, automatically these activities are going to stop, and in the absence of these activities, one can't expect the life. One can't expect the cell to survive. These are very vital activities which must go on in order to keep the cell alive or the organism alive. The question is, how the organisms living in the natural ecosystem or environment derive their energy. What is the fundamental source of energy? Usually, fundamental source of energy to the ecosystem is derived from the sun, particularly the sunlight. You all know that sunlight is usually having one particular wavelength which is going to be useful for the entire living kingdom. That wavelength of light that is absolutely helping to derive the energy is supposed to be photosynthetically active radiation. This photosynthetically active radiation is abbreviated in short as PAR, P-A-R. And this PAR is having the wavelength ranging from 390 nanometers to 760 nanometers. The sunlight belongs to this particular wavelength is considered as photosynthetically active radiation. The reason is light of only this particular wavelength is going to be used by the plants for the process of photosynthesis. Why we are talking about photosynthesis? One may ask the question. Because photosynthesis is one such process where light energy is going to be converted into chemical energy. And this chemical energy is assimilated in the form of food materials like carbohydrates. This is all going to happen there in all the green plants, because the green plants are having a light harvesting pigment called chlorophyll. With the help of the chlorophylls, light energy is converted into chemical energy, and the same is being assimilated or stored in the form of carbohydrates. Always carbohydrates acts as what? Carbohydrates acts as source of energy. And all the consumers we know that animals are considered as consumers. Whenever they feed upon the plants, the carbohydrates which are present in the plants is getting transferred to animals. Maybe there is a direct transfer of energy or indirect transfer of energy, whatever it may be. But here energy is getting transferred from plants to animals. Just assume that if the green plants are not going to carry out this process of photosynthesis, what would have been happened? Here transformation of light energy to chemical energy has not taken place. If this chemical energy is not produced, then absolutely there is no synthesis of carbohydrates in the plants. And there is no further supply of energy in terms of carbohydrates there to the animals. So the whole living system is deprived of energy. That is why we say that the fundamental source of energy to the entire living system is sunlight, the light energy. The question is, once the plants are deriving the energy from the light, what happens to the animals? Do all that energy present there in the plants is getting transferred to animals, or only some part of energy is getting transferred to animals? Let me consider that under the heading energy for entire systems. Okay, let me consider this now. Okay, assume that green plants, which we consider them as producers. Okay. They usually derive the energy from the sunlight. Sunlight acts as a source of radiant energy, We'll also call this as light energy. All that light coming from the sun is not going to be used by the green plants. It is known that hardly 1 to 2%, remember, hardly 1 to 2% of the sunlight is going to be used by the green plants for getting the process of photosynthesis done. Actually, the green plants, no doubt, photosynthesis process is going on. And how we are usually measuring the energy that is going to be captured by these green plants? It is usually said that it is calories per square centimeter, calories per square centimeter per minute. Like this, we are measuring the energy. Assume that when the light falls on the green plants, in about 8 to 10 hours of time, or in 8 hours of time, maybe the green plants which are producing the carbohydrates, which are worth of 1 lakh kilocalories. Energy of this much is going to be fixed by the green plants through the process of photosynthesis by manufacturing the food. Green plants, no doubt, they carry out the process of photosynthesis by using the light energy, and they are going to prepare the food, and this food acts as a source of energy. Means whenever the food molecules, whatever it may be carbohydrate, it may be a protein, it may be a lipid, whenever the undergoes breakdown, the energy present in the food molecules will be released. Means here, energy is captured, it is stored in the form of food molecules. What happens is, you all know that producers, they are the organisms belongs to fast food protein. There are also organisms which belongs to second trophic. The organisms which belongs to second trophic level are usually the primary consumers. We consider them as herbivores. Okay. When these primary consumers, they eat upon the producers. No doubt, the energy that is present in the green plants is a form of food, is getting transferred to animals. How much energy is going to be transferred? That's important. Do all that 1 lakh kilocalories of energy produced by the green plants in one day time, is it going to be transferred? No. Suppose if the animals feed upon the plants, such as producers, at that time, the energy that is equivalent to 10,000 kilocalories may be transferred. During the energy transfer, most of the energy is going to be lost in the form of heat. Energy is dissipated in the form of heat. Okay. And still certain amount of energy is going to be used by these green plants. Okay, usually for their own metabolic activities, maybe the growth, maybe the reproduction. Okay, even it may be the cell division, it may be the synthesis of important anabolic chemical compounds, such as hormones. definitely energy is going to be used. The energy is going to be used by the organisms they themselves in order to carry out the metabolic activities. Okay. Certain amount of energy is going to be wasted here. Okay. And still certain amount of energy is going to be lost during the transfer of energy from one tropic level to the next tropic level. Assume that there are third tropic level organisms present. Okay, usually in the third tropic level, you can observe the secondary consumers. Secondary consumers are present. And these secondary consumers are the one, they feed upon primary consumers. Usually they are carnivores. They feed upon the herbivores. At that time what happens is, okay, the food present in the primary consumers is getting transferred to secondary consumers. Transfer of food means it is transfer of energy. How much amount of energy? That's very important. Here, the energy that is getting transferred is equivalent to 1000 kilocalories. Remember, all the 10,000 kilocalories of energy that is being available to the primary consumers is not going to be available for the secondary consumers. The reason is, yes, here also these primary consumers are going to use energy to carry out their metabolic activities. And some part of energy is going to be wasted. It is going to be wasted during the transfer in the form of what you call as heat. Like that, supposing fourth tropic level organisms present there in the ecosystem. Usually in the fourth tropic level we find tertiary consumers. And these tertiary consumers are the top level carnivores. We call them as secondary carnivores. They get their energy by means of feeding upon secondary consumers. What happens is, all that energy that is present in the secondary consumers will not go to the tertiary consumers. Here, tertiary consumers are able to get only 100 kilocalories of energy. Again, what happens is, some part of energy is going to be used by the organisms to carry out the metabolic activities. Okay. And still some part of energy it is going to be lost in the form of heat. As a result of that, maybe only 100 kilocalories of energy is going to be accumulated. Okay, this is how the transfer of energy takes place in the ecosystem from the organisms of one tropic level to the organisms of another tropic level. Always remember, during the transfer of energy, always the energy is going to be lost. As a result of that, when we move from lower tropic level to organisms of higher tropic level, you find gradual decrease in the availability of energy. Here, for the producers, it is 1 lakh kilocalories. For the primary consumers, it is 10,000 kilocalories. Say, for secondary consumers, it is 1,000 kilocalories. For tertiary consumers, it is just 100 kilocalories. Yeah, gradually, what happens is the availability of energy is getting reduced. Then, You may ask the question here that this energy flow in the ecosystem, is it going to obey any laws of physics, any laws of what you call as thermodynamics? Definitely yes. During the transfer of energy in the organisms of the ecosystem, we find the laws which are 100% applicable to the energy flow in the ecosystem. Suppose if you consider the very first law of the ecosystem, what the first law of thermodynamics. Let me consider what the first law of thermodynamics usually says. First law of thermodynamics usually says that energy neither be created nor destroyed but can be transformed from one form to another. Okay. This is how the law says. Energy neither be created nor destroyed, but can be transformed from one form to another. Look here, any of these organisms, for example, consider maybe the tertiary consumers, secondary consumers, or the producers, they are not going to create their own energy. But what they do is, they are going to derive the energy. How they derive the energy? Very simple. Here, green plants derive the energy from the light. Their light energy is converted into chemical energy, and same is being assimilated in the form of food. And the energy that is present there in the producers is getting transferred to primary consumers. Suppose, assume if the green plants are not there, then absolutely you don't find the existence of other protein level organisms. There will be no primary consumers, no secondary consumers, no tertiary consumers. Because all these consumers, they depend upon green plants for their food, for their energy. Here simply what happens is, simply transformation of the energy takes place from one form to another form. Here, light energy is converted into chemical energy. And this chemical energy is going to be used by the organisms. Means any of these organisms which are present in the ecosystem can't derive their energy on their own. They can't create their energy. Okay. Simply they can transform energy from one form to another form. The light energy can be transformed into the chemical energy in the form of food. And the same is being transferred to other level organisms. This is with reference to the applicability of first law of thermodynamics to the energy flow in the ecosystem. Okay, let me consider the second law of thermodynamics. What is the second law of thermodynamics usually says? The second law of thermodynamics, it says something like this. %, I mean 100% energy transformation is not possible. It's not possible. Always during energy transformations. always during energy transformation, loss of energy occurs. Okay, this is how it states. Since you can't convert all the energy that is present in one form to another form, even whenever the energy transfer takes place, 100% energy transfer is not possible. During the transfer of energy, always loss of energy occurs. Look at this. Here, green plants manufacture the food and they produce the food in one particular day, worth of 1 lakh kilocalories. When the primary consumers eat some of these plants, actually what should happen? All these 1 lakh kilocalories available in the green plant should be transported or almost could accumulate here. But how much energy they get? They get only 10,000 kilocalories. Means just 10% of the energy present in the producers goes to primary consumers. Means here most part of the energy is used by the metabolic activities. Even some amount of energy is going to be lost in the form of heat. Okay, both can contribute up to 90% loss. Like that, if you consider the transfer of energy from primary to secondary consumers, during the transfer of energy, what happens here? Say, all that 10,000 kilocalories of energy available to the primary consumers will not be available for the secondary consumers. Hardly 1,000 kilocalories of energy is available out of 10,000. What happens here? Here, primary consumers use the energy for their own metabolic activities, and during the transfer of energy, some amount of energy is lost in the form of heat. Again, here we find 10% energy transfer. What happens to the next topic level organisms? You just look here. Here also, we successfully find only the 10% transfer of energy. Hence, during the transfer of energy from one topic level organism to another topic level organism, here most of the energy is either lost in the form of heat or it is going to be used by organisms for their own metabolic processes or activities. The second law of thermodynamics is also called as 10% law. We also call this as 10% law. Means only 10% the transformation of energy can take place from one form to another form. Remaining 90% of the energy is going to be lost, either in the form of heat or in other forms. Both the laws of thermodynamics, first law as well as second law of thermodynamics, are applicable to this what you call as energy flow in the ecosystem. I hope that it is clear. Then let me consider the other terms which are concerned to the energy flow in the ecosystem. What is the grass? Primary productivity. And net primary productivity. Gross primary productivity. It is abbreviated in short as GPT. What does it mean? It means the energy trapped, total energy, you can say, the total energy trapped by the organisms. In unit area and time. It's in the given area, in the given time, how much amount of energy that is being captured by the organisms. We refer it as gross primary productivity. Okay, say for example, unit time means I am just going to take 1 hour of time. Consider this. 1 hour of time. Unit area means maybe 1 acre of grassland. It is a unit area. It's the given area. All the green plants that are present in 1 acre of land, in 1 hour of time, they carry out the photosynthesis process. By means of carrying out photosynthesis process, they are able to utilize the light energy, which is able to produce the food equivalent to 1 lakh kilocalories. Here, 1 lakh kilocalories equivalent amount of food. It is being captured by the green plants by the way of photosynthesis in 1 hour of time, in 1 acre of time. But we call this as gross primary productivity. The total amount of energy that is being captured by the organisms in a unit time and a unit area. Then consider the net primary productivity. Net primary productivity means the amount of energy available, the amount of energy available to the organisms after using it to the metabolic processes. Very simple. Once the producers of green plants, they are able to produce the food that is equivalent to 1 lakh kilocalories. Don't think that all this energy is available to the plants for the transfer to the next level organisms. What happens is these green plants are going to use most of the energy that they derive for their own metabolic processes. Maybe for the cell division, maybe for the growth, maybe for the excretion, maybe for the circulation of nutrients, absorption of nutrients. Yes, these are all the vital activities which are going to occur by using the energy. And for conducting these metabolic activities, yes, organisms are going to use their own energy. Okay, assume that if they manufacture energy of 1 lakh kilocalories, maybe for the metabolic activities, they are going to use 60,000 kilocalories of energy. Then how much energy is available for the transfer now? It is just 40,000. 1 lakh minus 60,000, it gives 40,000. 40,000 is nothing but what? 40,000 is supposed to be the net primary productivity. And this net primary productivity is represented in short as NPP. NPP can also be represented in the form of equation like this. NPP is equal to GPP minus energy used for metabolic activities. Okay, like this we can calculate this. Here NPP means net primary productivity. It is how much that we do not know. Say, what is the gross primary productivity? If you consider it with reference to the producers. Okay, here gross primary productivity is just 1 lakh. Assume that is 1 lakh. Energy used for the metabolic activities. How much? Okay, just assume that it is supposed to be 60,000. Okay, 1 lakh minus 60,000. It gives the difference of how much? It gives the difference of 40,000 kilocalories. And this 40,000 kilocalories is actually the value of NPP, that is net primary productivity. And this much amount of energy is used for the transfer to next level organisms. I hope you have followed the things, and in the next class I will discuss about ecological pyramids. What are ecological pyramids and how the ecological pyramids can be drawn, and what are the rules that you are going to apply while drawing the ecological pyramids. Okay, till then, goodbye. Thank you.